All right, we are working on this proving angles relationship worksheet, and in the previous two videos we proved two theorems. Excuse me, the linear pairs theorem and this congruent supplements theorem. We used logic and deductive reasoning along with some definitions, theorems, and postulates to come up with these new mathematical ideas that we can now use. Okay, in this video we are going to prove the vertical angles theorem. Okay, that was the other one we proved in class today. So if you missed class on day one, this is for you. Also, if you just need a little bit more experience with proofs and you were in class, you can go back and watch this and practice. Okay, so here's how the vertical angles theorem goes. If two angles are vertical angles, then they are congruent to each other. Okay, so if we want to write a proof for that, then what we're going to do is take the if part and make that our given, and we're going to make the then part the hypothesis, and that's what we're going to be trying to prove. Now we can draw a representative figure. We can't add anything that we are not allowed to assume, so everything we're going to draw here is basically going to be part of the assumption that we're making, and we're going to prove that these angles are congruent. So what do we need? We need some vertical angles. So we're going to draw some vertical angles, and we can label the angles involved in that figure. Okay, so just to kind of review, vertical angles are formed when two straight lines intersect. So I'm going to do two straight lines intersecting here. Okay, and I'm going to call this guy angle 1 and this guy angle 2. Okay, so given angle 1 and angle 2 are vertical angles, what we're going to prove is that angle 1 is congruent to angle 2. Okay? Actually, just so it's like similar to a proof we did before, it doesn't really matter at all. Let's just call this one angle 3, and we'll say angle 3. So angle 1 and angle 3 are vertical angles. Angle 1 is congruent to angle 3. Again, it doesn't matter. The only reason I did that was because if I do it that way, it'll match the other proof we did really closely. But again, you could have called them angle 2 and angle 4. You could have called them angle A and angle B. It doesn't really matter. Okay. Now in this situation, we have these two angles that are vertical angles, right? They're across from each other. So these are also vertical angles. We could call this like 2 and 4, right? We don't really need to deal with those ones, but we are going to use this one as a helper angle. So while we're labeling these, let's call this guy angle 2, and it's not a vertical angle with either of these, but we are going to use it. Okay, so that's kind of our figure. We didn't necessarily add anything that we couldn't assume, right? We know we're going to have vertical angles. Obviously, we'd have this other set of angles. So let's go ahead and like make our two columns here. Okay, so statements, reasons, or justifications. Okay, we're going to start with angle 1 and angle 3 are vertical angles. Okay, a lot of times in proof, you'll see this angle symbol used as an abbreviation, so that's fine. Okay, that was given. Now this is where we're going to go. This is what we're trying to prove. This is like our thesis statement. We're going to finish it down here in our conclusion, but this is where we're headed. All right. Now, if you look at these two guys for a second, you'll notice that these two are a linear pair, and these two are a linear pair. Okay? So that's going to be kind of useful based on the figure that we have. So I would say angle 1 and angle 2 form a linear pair. And in the same line, I'm going to say the same thing about 2 and 3 because it's the same logic. Angle 2 and angle 3 form a linear pair. And the justification there, get a little closer for you. So angle 1 and angle 2 form a linear pair. Angle 2 and angle 3 form a linear pair. That's just the definition of linear pair. Right? We can see that these are two adjacent angles whose non-common sides forms opposite rays. All right, now we recently proved a theorem over here on the previous page. We proved this linear pairs theorem. We showed that anytime you have a linear pair, the measure of the angles equals 180. So we don't have to go through this logic anymore. We've already shown this logic. Now we have a shortcut called the linear pairs theorem. So we can just jump right to the fact that angle 1 plus angle 2 is 180 and angle 2 plus angle 3 is 180. So check this out. So the measure of angle 1 plus measure of angle 2 equals 180. Okay, measure of angle 2 plus measure of angle 3 equals 180. And now our justification is a theorem that we've already proven. So linear pair theorem. Pretty cool. As soon as you use a theorem, it's part of your axiomatic system. It's now something that you can use in your future proofs. Okay, so we're going to do something really similar to what we did last time. Since they're both equal to 180, we're going to set them equal to each other. Measure of angle 1 plus measure of angle 2 equals the measure of angle 2 plus measure of angle 3. Okay, that's the substitution property of equality. Okay, we're going to subtract out angle 2 because what we're trying to show is that 1 and 3 are congruent, right? Well, here's 1 and here's 3, and here's 2 and 2. So if we subtract the measure of angle 2 from the left and the right, on the left we're left with measure of angle 1, on the right we're left with measure of angle 3. Okay, notice this is very similar to the last one we did. And so what we have here, the justification for that is the subtraction property of equality. Okay, so did we prove they were congruent? Basically. One more step to make it official. We'll say, okay, look, if the measure of angle 1 is equal to the measure of angle 3, then by definition, angle 1 is congruent to angle 3. That's the definition of congruent angles. Okay, so proving a theorem, the if is the given, the then is the prove. You draw a representative figure and label it so that you can use that as a helper. And you just basically translate this given into, using your figure, and this one using your figure. And then you just base your steps on other postulates, definitions, properties, or theorems. All right, in the next video, we'll talk a little bit about these linear pairs problems and these vertical angles problems. And then I'll kind of give you a heads up on the last few problems. Thanks for watching.